All right, guys, we're going to start going over your warm-up. In the first one, it says distribute, and so I think that's what I saw most of you doing. You would multiply the 7 and the 3, and then when you multiply x times x, what do you get?
Squared.
X squared, yep. And then 7x times a minus 2 would give you a minus 14x. Any questions on that? All right, today when we simplify, we're going to have some problems where we have to factor out a common factor. So remember that factoring out a common factor is just undoing that distribution. So the problem would look like this: 21x squared minus 14x, and we would factor out that common factor of 7x, and then in the parentheses we would put what's left, okay? So factoring out a common factor is just undoing distributive property. All right, next we're going to multiply these two fractions together. Multiplication is very straightforward. You just multiply the top by the top and the bottom by the bottom. You don't need a common denominator to multiply or divide. So 3 times 4, and then x cubed y over 2x. That's my first step, right? I just multiply the top by the top and the bottom by the bottom. 12 over 2 simplifies to what? 6, good. And then Escarlith, how about x to the 3 over x? X squared. And then we still have a y. And so the fraction's gone when our denominator's gone. Questions on 2? Okay. In number 3, we have one of the easier types of factoring problems because there is no number in front of your x squared. So when there's no number in front of your x squared, you can just find those numbers that multiply to 6 and add to 5 and put them in your factors. So what were the two numbers that multiply to 6 and add to 5? 2 and what? 3, yeah. And then x and x, that makes your x squared, and everything's positive, so these are both going to be plus. And I did hear a lot of you like thinking, oh, it's been a while since we've done this, I'm not sure if I'm doing it right. You can always check your answer by multiplying it back out. So x times x gets you the x squared. I have a 3x and a 2x, that makes the 5x, and then the 2 times 3 gives you the 6. So you can check and see if you did it. So these things are going to be helpful for us today because we're going to be simplifying rational expressions and we're going to be multiplying and dividing them. In order to simplify them, you need to factor. You need to do a lot of factoring. Why do you think these are called rational expressions? What word do you see in the word rational? Ratio, right? Ratio. So ratio is a fraction. So when I'm talking about rational expressions, I'm talking about fractions. Okay? And rational expressions and rational functions, this is a whole different type of graph. It's based off the parent graph, y equals 1 over x. Let's just look at that real quick. We're not graphing today, but it's kind of nice to know what kind of function we're talking about. So this is the parent graph for rational functions. Notice it has 2 branches. It has this branch and this one. Rational functions can actually have more than 2 branches too. And the reason it has these branches is because it has both a horizontal asymptote and a vertical asymptote. And like I said, we're not graphing today, but it's just kind of nice to know what kind of functions we're talking about. So what we are doing is simplifying, and the process for simplifying often involves factoring. Let's look at the first problem together. If I have 6x minus 6, I can factor out what common factor? 6. So I'm going to factor out the 6. And then 6 times x would give me the 6x, and 6 times minus 1 would give me the negative 6. So I factored out that common factor of 6. Can we do the same thing right here with the 9x minus 9? Okay, so go ahead and factor out your common factor of 9 right here. All right, so if you factored out a 9, you should have 9 here times x minus 1. When I know that these can both be divided by 9, you can put the 9 here, and if you're not sure what goes in here, just divide each term by 9. So 9x divided by 9 gives you x, and then the minus 9 divided by 9 gives you the minus 1. So these are replacing these. You could multiply first, or you could simplify first, but it's going to be easier to simplify first because I have x minus 1 on the top and on the bottom. Maybe I'll multiply now and then I'll simplify. It's kind of hard to figure that out, but we'll try it. So I have 2 times 6 is 12, and I still have x squared. And then on the bottom, I have 9x. I want you to take a moment and see if you can simplify that fraction. All right, Sydney, 12 over 9 becomes what? Anybody else get 4 over 3? Good, because we divide them both by what number? By 3, good. So we have 4 over 3. And then x squared over x becomes? Sydney, you might as well finish. X, very good. Okay, so we simplified this fraction by dividing them both by 3. And then when we divide the common base, you can subtract the exponent. So 2 minus 1 gives you 1. Questions on that one? Okay. Let's see. Next one, I want you to try the same thing. I want you to try to factor these. Notice you already have a 7n and a 7n. You can just cancel those right away. And then factor, common factor out of each of these two. Okay. All right, the reason I can cancel out the 7n and the 7n is because they are being multiplied. So division and multiplication will undo each other. So 9n minus 24, what can I divide both of those by? 3, very good. So if I divide them by 3, I get 3n minus 8. Now, here's a hint that can help you with some of the harder problems. This one's not too hard, but sometimes you're going to get a harder problem. Once you've taken out that 3 and you have 3n minus 8, it's a good guess that we're going to get a 3n minus 8 over here also. Okay? So if you do something and it's not giving you 3n minus 8, I would check it again. It doesn't always happen, but that's kind of how these problems are set up. 24n cubed minus 64n squared. What number can I divide them both by? 8. 8's the biggest number. And how many n's can I factor out? N squared, right. So I can take out n squared. I can't take out n to the third because this one doesn't have enough. And I don't want to just take out n because I want to take out as many n's as I can. All right, 24 divided by 8 is 3. And n to the 3 divided by n squared is n. 64 divided by 8 is 8. And n squared divided by n squared, that's canceling. So just like I said, it should be a 3n minus 8 and a 3n minus 8. And then we can cancel those out. And we're left with just 3 over 8n squared. All right, looking at problem 3, what will be different about our factoring in this problem? All right, so I think that was Landon pointing out the bottom left one. Has a different kind of factoring. This one is going to work like what part of our warm-up? Part C of our warm-up. So you'll have a common factor to take out here and here. But for this one, we're going to factor it by finding the numbers that multiply to your last number and add to your middle number. Okay, so I want you to take a few minutes and work on 3 now. Okay, here we go. Let's look at the numerator here. Jennifer, what number did you factor out? And when you factored out a 10, what did you have left in the parentheses? Uh-huh. All right, Nick, in the denominator, how did you factor? All right, does anybody have a question for Jennifer or Nick about how to factor these two? Antonio, did you get that part so far? Okay. All right. Down here, we need to factor out a common factor of 5. And what do we have inside the parentheses? Yeah? Okay. All right, so that's instead of this and this and this. So now we can start canceling things out. I can cancel out the x minus 4, and what else? The x plus 3. All right, and so then I have a 10 on the top. And I have 5 times x minus 2. Can I do anything else here? Yeah? What is it?
Yeah, you can simplify.
Okay, so 10 divided by 5 is?
It's 2 over 2, 2 over 1. Or 2.
So
Over
all of this really.
X minus 2.
Now, I want you to talk to your group about this question. Why can I not cancel these 2's out? I've got a 2 and a 2. Tell your group what you think. Why can I not cancel those 2's out? Good. So just to review this one, we said we are done because division and subtraction don't undo each other. Over here, I saw you guys multiply to get 36 x to the 3, y to the 5. Oh boy, what was 9 times 16? 144. And then x squared, y. Did anybody simplify 36 over 144 already? What was it? 1/4? Okay. So 1/4. And then x to the 3 over x squared gives you x. Good, because you're subtracting your exponents. And y to the 5 over y to the 1. Y to the 4. Do you need this one here? Not really. It's fine to leave it there, but you can also just write it as x y to the 4 over 4. Any questions on that side? All right, let's go to the back. All right, we are dividing. Dividing just adds one extra step. It's not a big deal. Here's dividing with letters. Here's dividing with numbers. Sometimes the numbers are easier to look at. So if I want to do 1/2 and I want to divide it into fourths, then it can be become 1/2 times 4 over 1, which is the reciprocal. Literally what you're doing when you divide 1/2, here's 1/2, and I want to know how many fourths are in 1/2. Well, let me make the fourths. There are 1, 2 fourths in 1/2. That's why 1/2 divided by 1/4 is 2. But mathematically, you can do that by changing your divide to multiply and flipping your second fraction. All right, so let's do this problem real quick. We have 3/7. We change the divide to, what do we change divide to? Yeah. And then 5 over 12 becomes 12 over 5. Does that simplify? Right. All right, so do you guys see how a division problem is really no harder than a multiplication problem? There's just that one extra step. Okay, let's do number 1. And then multiply the top times the top and the bottom times the bottom. All right, if you have an answer, compare it with your neighbor. I'm getting 8x. Anybody else getting 8x? And it did. Okay. All right, in number 2, you can factor first, but I think I personally find it easier to flip it and then factor. So I'm going to just leave it the same, and then I'll factor. All right, so if you flip it, now it's just a multiplication problem, no different from the front. Does anybody remember how to factor x squared minus 4? Or do you even remember, like, what's that called when we factor x squared minus 4? It's a difference of what? See, right? Difference of squares, are they both squares? Well, x squared is a squared, right? Is 4 a square? Yeah, 4 is the square of 2. Okay, so it is difference of squares, and the pattern is a plus minus pattern. So it would factor to be x plus and x minus. And what number goes in here? X times x gets me x squared. What times what will give me negative 4? 2 and minus 2, yeah. Okay, so that becomes this. Down here I can take out a common factor of 3. And then I can cancel a couple things before I start to multiply.
Plus 2.
Yeah. And actually, maybe I'll just start with that. Do not distribute anything to the parentheses to start because we might have more things canceling. So the 16y squared can go first, and then the x minus 2. I can multiply the 3 times the 20 to get 60, and y to the 4. Okay, 16 over 60. What's that going to be? I think they both divide by 4, right? So 16 divided by 4, 60 divided by 4. What fraction do you get? 4 over 15. Nice. All right, y to the 4 and y to the 2. It's going to give me y to the 2, but does it go on the top or the bottom? The bottom, right, because you have more y's on the bottom. So it's going to be y to the 2 on the bottom, and then this x minus 2 here. Some teachers will have you stop right there, and you're good because nothing else cancels. Some teachers will have you distribute, and I'm actually not that picky. It's fine with me either way. You can decide to distribute that 4 and get 4x minus 8 on top, or you can leave it factored like that because nothing else simplifies. All right, let's look at 3. In number 3, we're dividing by this, and it's not a fraction, so how do I flip it? I could put it over what number?
1.
Thanks, Layla. All right, so now I can rewrite it. 2x squared minus 5x plus 3 over 2x squared times 1 over 2x squared minus 3x. Okay, we've got something to factor that we have not factored yet today, but we did factor way back, and that is a trinomial where your a value is not 1. So we need to talk about how to do that. I don't really have a lot of space for it either. I'm going to use a piece of scrap paper, I think. If you have a piece of scrap paper, you might want to use that as well. All right. So this time when we find the numbers that multiply to 6 and add to negative 5, we can't factor right away. We have to do an extra step. What are the numbers that multiply to 6 and add to negative 5? It's going to have to be a negative times a negative, right? Negative 3 and negative 2, yeah. Okay. So now what we do is we rewrite this one, 2x squared, and we replace the negative 5x with a negative 3x and a negative 2x, and we bring down the plus 3. Okay, you will want this review of factoring. It's going to show up in your Delta Math homework as well. All right. From the first two, we can factor out a common factor of x. From the second two, it looks like they have nothing in common, and it's really kind of true, but I do want this to match up to be a 2x minus 3, so I'm going to factor out a negative 1. By dividing this by negative 1, the 2x becomes positive, and the 3 becomes negative, and now they match up, 2x minus 3, 2x minus 3. Then, one of your factors is the inside, the 2x minus 3, and the other factor is the outside, the x minus 1. I'm going to leave that there because I know it takes a minute to digest that. So now that I've factored that, I'm going to replace 2x squared minus 5x plus 3 with its factors. 2x minus 3, x minus 1. And then here I can factor out a common factor of x. And I end up with 2x minus 3. Is anybody still writing this one down? Okay. All right, so I can cancel out this and this. 1 times x minus 1 is just going to give me x minus 1 on top. I have 2x squared times x. What is 2x squared times x going to be? 2x to the what? Yeah, 2x cubed. 2x to the 3. All right, that's a little bit small, but that's a 3. We're going to do one more problem together. The challenge problem is going to be for you guys to do on your own. I'm not going to do that with you because it's a challenge. But we're going to do, we're also going to do whiteboards today. So the challenge problem will probably be for after the whiteboards. You may choose to do it after your Delta Math as well. That's fine. All right, let's look at the last one. So very first thing I'm going to do is just change it to a multiplication problem. So 5x over 3x minus 12 times x squared minus 6x plus 8 over x squared minus 2x. Okay. Once it's a multiplication problem, I want you to try to factor everything and cancel. And I'm going to give you a couple minutes to work on that. 3, yes. Okay, second denominator. We could not factor out a number, but we could factor out what? X. So we're going to factor out x. All right, and then here I need two numbers that multiply to positive 8 and add to negative 6. Did you get them? Negative 4 and negative 2, good. I find it very satisfying to cancel things out. Just like how nice and neat everything is. So x minus 4, x minus 4, x minus 2, x minus 2, x, and x. And it just leaves me with what? 5/3. Done. Beautiful. All right, so I'm not going to work through the challenge problem right now. I am going to leave that up for a moment so you can finish your notes.